varied areas related to sensing, microwave technology, bioinformatics. And quickly, before we start over for the presentation, I would take the privilege to welcome our esteemed speakers who are here, the paper presenters who are here from the globe, and the papers which we have received across the globe from USA, Canada, UK, Singapore, Tashkent, Dubai, and certainly Australia. So I am indebted to all the authors who have wholeheartedly participated in this conference. In all, we have received 602 number of papers and the conference, and we have out of the peer-reviewed and the blind peer-reviewed, which was a rigorous process in which the 193 papers have been registered for the IEEE ICC ETM 2025. Going further, the session right now, which we are starting with, is the session which is related to the paper presentation. At 11 o'clock, we are starting with the inaugural session. So hereby, I invite Alicia to present her paper. Uh, she, um,
The reconfigurable bandstop surface for beyond 5G,
Complete that.
6G application.
You can introduce it.
I'm Alicia, and I'm from University of Sydney as an undergraduate student in software engineering. So this is what I'll be discussing today. And this is the outline that I'll go through. So the introduction, then I'll talk about related works, then my work, and then future work. So to give background, I would like to discuss the evolution from 5G to 6G, or fifth generation to sixth generation, as this is where my work focuses on. So 5G communications laid the important foundation, which introduced new radio interface, which supported enhanced mobile, broadband, and massive machine type communications. However, rising demands from smartphones and devices has revealed limitations of the current network and current spectrum. So this means like we are expected to reach over 5,000 exabytes by 2030. So therefore, a new spectrum, which is the D band, is urgently needed, making the transition to 6G communications. And this high frequency band allows ultra high data rates of 100 gigabytes per second and ultra low latency with latency less than 1 millisecond. Also, at this high frequency, this enables short wavelengths, which means antennas are physically smaller, allowing denser antenna arrays, pointing the beams of signals exactly where they're needed. And this makes connections stronger and reduces unwanted signals. However, there are challenges at these short wavelengths as free space path loss increases rapidly, while atmospheric gases such as oxygen and water vapor introduce strong absorption peaks that further attenuate the signals. Also, obstacles such as walls can interfere with the D-band beams, weakening or blocking them. Another challenge is the spectral congestion. As more users and devices operate in the D-band, multiple services must share the same limited, fragmented frequency blocks. Unlike lower bands with broad continuous allocations, the D-band is split across regions and licenses, and even small gaps or overlaps in this band can cause interference between neighboring cells or channels, leading to reduced throughput or reliability. So to overcome this, I'll use a reconfigurable meta surface, as this further improves performance, controlling how the electromagnetic waves move through the environment. A metasurface is a two-dimensional array of atoms which each give a specific phase shift, collectively shaping the wave. And generalized sheet transition condition found that these phase shifts are like jumps caused by induced electric or magnetic polarizations from the meta atoms. And by engineering these polarizations, metasurfaces can achieve beam steering, focusing, filtering, and more. So the reconfigurability comes from when the metasurface is integrated with the tunable elements. These structures can dynamically modify the electromagnetic behavior, enabling functions such as adaptive filtering, interference control, or spectrum shaping all in real time. So my aim is to create a reconfigurable band stop surface to dynamically tune the stop bands in the D band spectrum using PIN diodes, hence blocking of narrow frequencies which could be unwanted in 6G communications. I will first discuss earlier studies to show how my work extends these previous developments. So this study presents a polarization independent reconfigurable metasurface using PIN diodes, and the design uses two layers. The top layer is a lossy layer made of square loop with resistors and PIN diodes, and then the bottom is a frequency selective surface enabling signal transmission. So when the diodes are off, the structure acts as a frequency selective resorber, providing a transmission window at 4.28 gigahertz. And then when the diodes are on, it switches to absorber mode and achieves 90% absorption across 2.8 gigahertz to 5.2 gigahertz. Also, a prototype was fabricated using PCB technology of validating the simulation. So therefore, this study offers a compact and tunable solution for adaptive electromagnetic interference suppression and also stealth applications. So the next study presents a reconfigurable metasurface design to achieve tunable band gap in the C-band spectrum for radar cross-section reduction. So they optimized the geometry, and this achieved a wide 1.2 gigahertz bandwidth, making it suitable for broadband radar and stealth applications. PIN diodes were also integrated into the meta-atom, allowing resonant frequency to be electrically shifted as well. And when the diodes were off, the surface resonated at 5.23 gigahertz. And then when the diodes were on, it shifted down to 4.75 gigahertz. Also, they had an array of 128 active cells fabricated and experimentally validated. And so this confirms the strong frequency tunability in the C-band spectrum. This last study introduces a reconfigurable metasurface as well, where the stop band is shifted across different spectrums using the PIN diodes. So the design is based on a rectangular loop meta-atom where the diode biasing dynamically adjusts the stop band frequency. So under transverse electric polarization mode, there are three modes observed, where the first one focuses on the Q band and finds a shift from 12.64 to 14.75 gigahertz. And then mode 2 focuses on the C and X band spectrums and finds a shift from 6.62 to 11.28 gigahertz. And then mode 3 focuses on the X band spectrum and finds a shift from 9.82 to 11.63 gigahertz. And then also in the transverse magnetic polarization, there was a shift found from in the X band spectrum from 9.05 to 11.29 gigahertz. They also had a prototype fabricated and measured, and this shows how there was real-time tunability across the three microwave bands and polarization adaptability. So my study extends this, where I use PIN diodes to to electrically tune the stop band with a reconfigurable band stop surface. Yet I focus more on the D band spectrum to help the 6G communications, focusing on transverse electric and transverse magnetic normal modes using different meta-atom structure and materials. So using the HFSS simulation, I designed and simulated a meta-atom which includes a square Rogers substrate with 0.254 millimeter thickness to stabilize the resonance, and two square split ring resonators on the top layer and a circular one on the bottom with zero thickness, and all being perfect electric conductors. So they behave like LC resonance circuits where the metal rings provide inductance and the gaps act as capacitors, together determining the resonant frequency where the electromagnetic waves are reflected, creating the stop band. Also, pin diodes control the tuning of this stop band, where they are placed across the intergap between the nested top rings and across the split gap of the bottom circular ring. They can either be turned on, being perfect electric conductors, short-circuiting the split ring resonators, or just be vacuum state or vacuum space. So these diodes create four switching states where all the diodes can be switched off, or they can all be switched on, or only the top ones are switched on, or only the bottom one is switched on. And this shifts the resonant frequency through creating effective inductance and hence tuning the stop band across the D band spectrum, enabling reconfigurable electromagnetic interference suppression for 6G. I also applied master-slave boundaries to the opposite faces to simulate an infinite array of meta-atoms and hence represent a meta-surface. And this is in the X and Y direction. This means that one cell or meta-atom represents the entire array. And then Floquet ports excitations are used to excite the structure with plane waves, assuming it repeats endlessly in the X and Y direction, hence assuming a metasurface structure. So in the analysis setup, the metasurface was analyzed under the full D-band spectrum, and a linear frequency sweep with 100 megahertz step size was used to allow fine spectral resolution around each resonance. And then only the transverse electric and transverse magnetic normal modes were excited. And then the output analysis focused on the S parameters, as at such short wavelengths, the D-band spectrum is hard to observe far-field tests. And then also these parameters, coefficients can help find a stop band. So looking at results of sweeping the D-band frequency for the different diode states, these figures here present the S parameter results for the metasurface operating in transverse magnetic normal mode. Starting with all diodes off, a stop band was found at 156 gigahertz. A secondary stop band, a little bit weaker, was found at 126 gigahertz. And then the reflection coefficients found 0 decibels around these frequencies, further confirming the stop bands. And then when the bottom diodes were turned on, the stop band shifted to 148 gigahertz, and then the other stop band near 126 gigahertz became deeper attenuation. And then when the top diodes were on, the stop band was found at 148 gigahertz as well. And also when all the diodes were turned on, it shifted down towards 142 gigahertz. And also a band pass was found at 126 gigahertz when all the diodes were on. So next, these results here show the transverse electric mode, normal mode, starting when all the diodes were off. You can see a clear stop band at 110 gigahertz. And then when the bottom diodes are on, it shifted to 109 gigahertz. And then when the top diode is on, the main stop band moves upwards to 116 gigahertz. And then when all the diodes are on, it shifts to 114 gigahertz. So these results confirm that the metasurface tunable stop band behavior across a 7 gigahertz range in transverse electric polarization, and then a 14 gigahertz range for transverse magnetic polarization, demonstrating a reconfigurable metasurface, which is potential for dynamic suppression of frequencies in both modes in the D-band spectrum. I then looked at shielding effectiveness, or I'll just say SE, as this is a critical performance measure that determines how effectively the structure can suppress unwanted electromagnetic frequencies. So SE is defined as the ratio of incident field to the transmitted field, and it can be expressed as the negative of the S parameter transmission coefficients. So for the results, I focused on the transverse magnetic polarization as this had the greatest tunability range. And so when all the diodes were turned off and the stop band showed a peak at 156 gigahertz, this showed 35 decibels of frequencies blocked. And then when the bottom diode was on, this maintained a 33 decibel peak. And then also there was a rejection peak at 33 decibels when the top diodes were on as well. And then the highest rejection peak was when all the diodes were turned on, and this was at 40 decibels. So this shows how it is industry grade shielding performance for the D band electronics in all diode states. So therefore, by adjusting the on and off conditions of the pin diodes in the metasurface structure, this achieved a dynamic shift in both the transverse electric and transverse magnetic normal modes, confirming it works under different electromagnetic field orientations. However, I will state several limitations and assumptions, as the simulation assumed ideal conditions, neglecting fabrication tolerances and material losses, which may affect it in real-world performance. And then the diodes were modeled as perfect conductors, not reflecting the actual electrical behavior. And then additionally, edges and finite array effects were ignored due to the periodic boundary setup of being an infinite array. So looking ahead, the next stage of this research is to focus on advancing from simulation to practical implementation and real-time adaptability. So first, by integrating Python with HFSS simulation, this can automate parametric sweeps to generate large, realistic datasets. And then this will enable machine learning models to predict and optimize metasurface performance in real time, improving the design efficiency. Second, hardware prototyping and experimental testing will validate the results. And this is crucial since small geometric or material imperfections could shift the resonance. And then finally, the ultimate goal is to create a real-time coded metasurface where each meta-atom can be a diode state represented with binary numbers. And then these binary controlled patterns can dynamically block or redirect electromagnetic waves, paving way for smart surfaces in the future 6G communications. So overall, this presentation shows how a reconfigurable bandstop metasurface can be electrically tuned with pin diodes to dynamically shift the stop band in the D band spectrum, showing suppression of frequencies that could be unwanted in 6G communications. Thank you.
Was an excellent presentation, Alicia. Thank you so much on behalf of your team. And uh, before we move ahead, I would request the session chair, Professor Masood, who is from University of Canberra, to have a quick question on the PPT, please.
Thank you. It's good. Very good. It's a very nice presentation. I think the work you've done is very interesting. With the diodes, at the moment, you just switch them on and off, and then the top and bottom ones, and in the simulations software.
Yeah, so basically I would have a sweep of the spectrum on one of the states, and then I would change the state of the diode and then sweep again to get the results in the different states.
So you can manipulate the frequencies and with the diodes in a sense.
Yeah. But I haven't like done it right now because I'm just using a simulation.
Right.
So, but yeah, that's what would happen if it becomes practical.
Yes.
You
One
just
more
change it.
question. You mentioned at the end, with the machine learning and collecting data,
Yeah.
etc. Of course, you can use optimizations to optimize, which diodes or which combinations of diodes you're going to switch on and off.
So basically, yeah, the goal is to have a coded meta surface. So it has many meta atoms, and then each meta atom has a different diode state switch on and off.
Yes.
Obviously, right now I have 4 diode states, so this will create only like 4 different diode states, but I can add more by adjusting the meta atom structure, maybe adding multiple layers
Yes.
or something. Yeah.
Very interesting. Yes. I wish you all the best.
Thank you.
Thank you.
Thank you.
Has your professor at the University of Sydney helped you, or
Yes, this is
yeah.
the end.
Okay, okay. What one can say, maybe you can join. Yeah.
Yeah,
Okay,
he was
but
really
got a good
advisable.
presentation. Yeah, you are in the final year, or
Yeah, final year of
okay,
my undergrad.
okay. But have you studied some models before? Are you taking inspiration from some models, or this is your original work?
So this is my original work, but I have looked at previous like different meta atoms and meta atom structures in the different like the future work that I was talking about, like their work in the different spectrums. So their structures are kind of different because they're looking at different spectrums.
But are you taking a help of the industry also? Have you been able to, or your professor has helped you to send
Yeah,
it to the?
like sort of not.
More than enough hours available.
Okay, okay. Right.
She just mentioning that this work she doesn't have the required background,
Wow.
but she still want to do in this.
Yeah.
Great.
Without like extensive previous knowledge, I believe
That's really
very great.
absolutely.
Yeah, because I'm a
Absolutely.
software engineer, and this is obviously very electrical engineering vibe. So
Yeah. Yes. All the best. Thank you.
thank you.
I can't see the slides moving. Let me see what's happening. So if I share here. Now the slides are moving in.
Okay.
Yeah.
Great.
Perfect.
That's
So we
very
have to
helpful.
share the screen. When we put it in a presentation mode, we share the screen. This is screen, which is this one.
That's great.
Yeah, screen 2. And we remove it from there. Perfect.
Okay, so wonderful presentation by Alicia from University of Sydney. And now I invite Mohammad Abu Sayem, who is from University of Technology, Sydney, who is presenting on behalf of Professor R.A. Begum from Western Sydney University. Thank you so much for coming in.
Already lost the slides. Paper 737.
Can share the screen. Come.
We go to a presentation and go.
I think the blue one is your PPT, right?
Yeah. Remove it from here.
Okay. Thank you.
Yeah. It's
Thank you.
right. Okay, thank you, everyone. Good morning to distinguished guests, respected colleagues, and fellow researchers. My name is Mohammed Abu Saim, and I will be presenting our paper titled Data-Driven Neural Network Model for Smart Bin Waste Level Predictions. So this research addresses one of the most pressing challenges in modern cities, how to manage urban waste efficiently using intelligent data-driven systems. So let's start with the introductions. As urban population grow, waste generation increases rapidly, making collections more complex. Traditional fixed schedules often lead to excuse me, often lead to overflowing bins of or unnecessary trips. Smart bins equipped with IoT, Internet of Things sensors allow rest time monitoring, but to truly optimize collections, we need accurate prediction-based levels. So neural networks with their ability to capture nonlinear and temporal patterns provide powerful solutions. Moving on to our research objectives, to develop a neural network model for predicting smart bin waste levels, to use multi-sensor Internet of Things data, including accelerometer readings, proximity sensing, ultrasonic distance, temperature, humidity, and battery voltage. And third one is to compare three architectures: feed-forward neural networks, cascade-forward neural network, and recurrent neural networks. Finally, is to evaluate the performance using root mean square error, mean absolute error, and mean absolute percentage error. So following other literature reviews related works, previous studies have applied artificial neural network, support vector machines, and multi-layer perceptions for municipal solid predictions. However, most face challenges such as limited data sets and poor temporal modeling. So recent research highlights the advantages of recurrent neural networks and convolutional neural networks for time series forecasting, which inspired us to focus on RNN for sequential waste accumulation patterns. So our methodology is to overcome data scarcity. We expanded our data set from 42 to 142 samples using interpolations. We train all models with a single hidden layer of 8 neurons using the Levenberg-McQuaid algorithms for fast convergence. So this setup allowed us to fairly compare feed-forward neural networks, cascade-forward neural networks, and recurrent neural networks under identical conditions. So let me walk you through the overall form framework shown in the flowcharts. So we structure process into three stages. Stage one is data pre-processing. So we expanded the data set using interpolations, collected sensor data such as accelerometer, proximity, ultrasonic, temperature, humidity, and battery voltage, and also normalized inputs. So next step two, is a model training. We train the recurrent neural network using the LMA to learn temporal patterns in base accumulations. Stage three, we have done the predictions and validations. So the most predicted waste levels, compare them with actual values, and performance was evaluated using MAE, RMSE, and RMAPE. The structured approach makes the model accurate, reliable, scalable for smart city applications. So about the recurrent neural network, let me briefly explain the RNN we used. Unlike traditional models, it designed for sequential data and includes feedback loops that help retain past informations. ideal for tracking how waste builds up over time. Our model used one hidden layer with 8 neurons and was trained using the LMA. This setup captured time-based patterns efficiently and converged quickly. So overall, the RNN consistently gave the most accurate prediction, outperformed the other models across error metrics. So on the 70% training ratio, the data set, the RNN consistently outperformed the other models across all input configurations. With 3 input features, the RNN achieved RMSE of 0.0433, significantly lower than the other models. And then with the 5 inputs, it maintains strong performance with a root mean square error of 0.1133 and a mean absolute percentage error of 3.04%. And then with 8 inputs, the RNN produced prediction closest to the actual values with a minimal error of 0.0168. So these results demonstrate the model's ability to generalize well and capture temporal dependencies effectively. For 60% training ratio, when the training ratio was reduced, the RNN network still delivered the best performance, although there was some instability was observed due to the smaller training set. So despite this, it achieved the lowest error metrics across most configurations, confirming its robustness and adaptability. This finding suggests that future work should explore ensemble learning and then hyperparameter training to further enhance stabilities. So in conclusions, the recurrent neural network provides superior accuracy for predicting smart bin waste levels. Multi-sensor input improves forecasting reliability. Data interpolation help expand the data set and improve model training. So this framework shows strong potential for real-time implementations in smart cities, enabling more efficient and sustainable waste management. Thank you very much for your attention.
Thank you so much. I'll quickly ask for the question, please.
Thank you for your great presentation and
you.
very interesting models that you have used.
Yeah.
Have you tried different models, or you just
So
the current
for
neural
the primary,
networks works well and you just decided to go ahead with it?
we have tried 3 models. So we have found that RNN gives the best results. So in future, we are planning for LSTM for bigger, larger data sets.
Right.
Yeah.
Do you do any optimizations on your models, or you just?
For now, no optimization. We just use the RNN algorithms. So
Okay.
we just want to see the stable. We see without optimizations, the system is stable. Yeah.
Right.
So we are planning optimization for larger data sets. So
Right.
we are expecting a larger data optimizations. Yeah.
With your data sets at the moment, how large is it? You know, because you mentioned, but I didn't understand it.
This is only with 42. We have increased to 142. We have extra added 100 more samples. So now
Right.
we are going for thousands. Yeah.
And what is the future of this project, if I may ask you? You know.
Future of the project. So like if the waste won't be overfilled, so it is designed for the smart cities. For current setups, it will go with the current setup, but the future, we are planning for larger places. So we have the more accurate data. So smart cities won't have a like overflow of the bins. So we will have more data sets. We can get more data. For this is a prototype level of work. Yeah.
And can I ask you one more question?
Sure.
Please? On the bins,
Okay.
where you collect the data,
Okay.
your sensors check the weight, or you've got the camera sensors?
We
you've got the
have
weight
sensors. We have used 8 sensors. So once it reached to our the red level, the sensor will detect to collect the pins.
Okay, that I think I better stop because I'm very interested in what you're doing.
Okay.
Because you know there's so many sensors you can use.
Yeah.
In the bin. You know,
Yeah.
humidity sensors,
Yeah.
temperature sensors.
Yeah.
So You can even, if the bin is not full and
Yeah.
it's very smelly, you can,
Yeah,
you
true.
can sense through
Yeah.
those senses.
All right.
Very interesting
All
talk.
right.
Thank you.
Okay, thank you so much.
Thank you so much. And it was a beautiful presentation. Now, may I please request Mohammad Nazmul Hussain from Australia Catholic University, who is accompanied by Professor Vilayat Hussain from Australian Catholic University, to present the paper, please.
No.
Yes, he's presenting on behalf of Professor Vilayat. Right. Vilayat Hussain. You share, this is your paper?
Yep.
Share the screen.
Okay. This is yours. Yeah? No, no, no. Which one? Which one is yours? Do we know?
No, no,
This is
not
your
here.
paper 77, no?
No. Last one, last one.
So,
Thank you.
Thank you.
Hello everyone, this is Nazmul Hussain. I'm a PhD student of Australian Catholic University under supervision of Dr. Walat Hussain. So today I'm presenting my paper on autonomous learning coach, a tech-centered agentic AI approach to effective learning. Agentic AI is a new word, so it's under research. So most of them maybe don't know about agentic AI. So it refers to autonomous AI that basically works without human intervention or minimal human intervention. So we know about AI and AI system, but very few of us know about agentic AI. But this is the future. So in future, there we will have many agentic AI system. So currently in different LLMs like ChatGPT and other sites, we can see it can work autonomously in some cases, in some few steps. So it don't need continuous input. So in future, you will be able to see there are lots of systems that is based on agentic AI. So agentic AI is special because it can set goal, it can plan its actions, and it can take the proper actions. And based on the action, it can get some knowledge, and with the knowledge, it can again perceive this knowledge for the next action. So it's just an autonomous process to reduce the human intervention. So in future, we will be able to see this agentic AI in different fields. So now in this research, we have applied this in our learning system. So how we can improve our learning system through agentic AI. So this research is a collaboration of Australian Catholic University and ReadyTech Technology. So I'm here, I'm Mohammad Nazmul Hussain. I'm presenting this one on behalf of my other authors. Yeah. So let me start with the motivation. So it will be easy for us to understand what is the research. So most AI tutors today behave like answer machine. Whenever a student type a question, it just provides the answer. So this is helpful, but this is not the proper way to learn or to help a student for learning new things. So we have noticed this problem in traditional AI system or traditional AI tutor-based system. So that's why this problem motivates us to do this research. So here from the figure, we can see that a student is asking a question to a AI tutor or normal tutor or traditional tutor. It just gives the answer. Or sometimes if it's okay, then it tells like it is okay. Then it's wrong, then it gives the accurate answer without helping student to think, to reason on this particular problem. So this is the gap we found, and we worked on this. And finally, we found if we help the student by giving some hints, by asking a couple of questions to confirm whether the student actually understand the question, whether the student actually got the point or not, or instead of understanding it, just guessing the answer. So this is our point. So this is our motivation and problem. And this brings us to the research gap and our aim. So here I have pointed some points about gaps in existing work and aim of this work. So you can see in the traditional intelligent tutoring system, they have some issues. If we want to set up intelligent system in a particular classroom using traditional system, we need more sensors, smart softwares, and also we need other stuffs that is not compatible in low resource settings. So this is a major problem in traditional system. And for LLM based tutors that we already have, it has some issue, like it's good for explanation, but it has risk of hallucination. So there are lots of problems in traditional and LLM based tutor system. That's why we are motivated to build some agentic AI system. And here it helps us to adapt the feedback, and it encourages for the second attempt and deeper thinking. So this is the overview of our architecture. So here the main components are control, that is orchestrator. For agentic AI system, the mandatory part is orchestrator, because the orchestrator connects with multiple agents. So I renamed this one as control, and then queue detection agent, student agent, planner, RAG retriever, and tutor agent. So here another point that I missed about agentic AI. Agentic AI is not as same as LLMs. So we know about LLMs like ChatGPT and other Gemini. This is not exactly agentic AI. So we can think different LLMs as a language generator. We are asking some question, they are replying. So agentic AI is more than the LLMs because it integrates different tools, memories, and other stuffs. So here LLM or ChatGPT or what you want to say. So it's just a part of agentic AI. Agentic AI is more than this. So here is an example of agentic AI. So we have control, that is orchestrator. It connects with multiple AI agent. One is queue detection agent, another one is student agent, then planner agent. We have a couple of agents here. So that works together. So whenever a tutor asks a question to a student normally replies the question, and based on the answer, it goes to the queue detector agent, because whenever a student gives some answer, it might be uh, correct, it might be wrong. So instead of replying that you are correct or you are wrong, here we are taking another step. So here it first identifies the queue. Student is actually given the correct answer or wrong answer. This is a division. Then another part is he is confused or he is confident. So based on student answer, it goes to the planner agent. Then planner agent plans accordingly. Like it gives students some hints. You can think twice, or it can give student another question like, "Are you sure?" So this is the process how it works. So the most important thing for agentic AI is perception, reasoning, and action. These are three important components for agentic AI. So here in the perception step, it actually reads student answer, detect misconceptions, low confidence, frustration, lack of explanations, and then it updates learner profile in student agent. For the reasoning step, it basically plans the strategy, what it needs to apply to the particular student, so that the tutor can confirm student actually understood their problem or their answer. So then it goes to the action level. So it can retrieve syllabus content when needed. RAG, we know RAG is retrieval augmented generation. So it's a term that uses with LLMs. So whenever we need some extra resources, we can get from the internet or other sources from the databases. So it is connected with LLMs. And then tutor agent generates the response. And finally, government checks safety and alignment before sending to the student. So whatever we get from the sources, we cannot send it directly to the student. Before that, we have to check the safety. So this is another process. And for this paper, we have checked the performance of our architecture. So for this, we initially created some some questions for the particular students. So students need to answer those questions, and based on the answer, the model works. So here I have created some math problems, and later I provided it to the students, and the question can be answered from option A to E. So based on the answer, I have evaluated into two conditions. One is baseline, another one is agentic condition. Baseline is direct, just traditional way. Is it correct or wrong? And agentic way is, instead of replying correct or wrong, we can ask a couple of questions. We can give some hints so that we can confirm the student is actually understand the question, and actually he is confirmed or he just gets the answer. So this is my results. So this table presents that at the very first time, we got a similar result, 80% accuracy from baseline and agentic AI based system. But later on, whenever we used agentic approach, because 20% answer is incorrect here. So if we ask 10 questions to the student, he or she might answer like eight questions perfectly, but 2 questions may be incorrect. So how we can help the student to understand that two other questions? So this is the result that I am presenting here. So we are giving some hints to the students. We are giving some uh, extra question to the student so that he or she can change her answer, and later we can see how this agentic approach helps to the students. But if we directly say you are correct or wrong, then student will be demotivated to understand what is happening here, or it will not be helpful for the students to understand the question. Also, here you can see the reflection rate and right to wrong conversion. So the wrong to right conversion is 20%. It means after giving proper feedback to the students through agentic AI system, we got 20% positive response here. And we have, for this research, we have used 4 different types of cues as explanation, frustration, hesitation, overconfidence. So these are the 4 categories we have used here to identify which category lies the student response. Based on these cue detections or cue response, we next the tutor reason provide student hints or another questions. So these are my results for the performance of Q encoder. So here I have used GPT 3.5 Turbo, and then auto detector, that is a rule-based system, and also as a human reviewer. So that if my system tells this student is hesitated, frustrated, as a human reviewer, what will be the response? Based on the student response, I can say, yes, this is correct, it's hesitated, frustrated. So we have added here human as a gold reviewer. Then we compared this one with GPT response with auto response, and we found that GPT is better than other systems here. So yeah, so this research is under process. So as this is a part of my PhD project, but my PhD is more than these things. It's a big project, and as a part of my PhD project, I have implemented this agentic AI tutor here. So this is not actually the prototype. This is already implemented, and I have received some good results from here. And I hope that it will be helpful for my actual PhD projects. But here I have some limitations because here I have set some questions for math course only, and it's not applicable for other sections because all the questions cannot be answered through like multiple choice. So some question can be answered through the text base, can be numeric. So I have to work on this in future, and also I have to implement this in real life classroom. So this in the future, I would like to extend to more subject and open-ended tasks and larger, longer classroom studies and a stronger hybrid Q model with teacher dashboard, so that teacher can also see student performance and the progress. Thank you so much.
It was an excellent presentation, and you also used your PhD work, and it's the latest one. I appreciate that. Now, may I request Professor Payam, who's the Associate Dean of the International from Western Sydney University, to pose a question, please?
I think people can hear. Just out of curiosity, that actual PhD topic, what would that be that this one is part of?
It's basically about education system. So, education system is a broad topic. So I cannot fit it in a in a conference. So it's just part of the education system. If here I'm highlighting only the tutor perspective, but in the education system, I have to think about tutor, student, and the
So
system.
your background is engineering or education?
Yeah, no, I'm from computer science department. Yeah.
Computer science. Interesting.
Yeah.
When you talk about agents, those agents are things that you developed or you just borrowed them and
No.
assembled them in the network?
Currently, we have very few AI agent system in the internet. It's under work. So I have developed these things. So later, I have just checked the performance through an actual data sets. Yeah, I have created this AI agent.
And to train those models, where you get your data?
Yeah, basically, I have prepared one question set first. Later, I provided it to the undergrad students. So there are like 40 students. So after getting their response, later I have checked the accuracy first. Later, again, I have checked, I provided the questions to them. And next time, whenever they answer, they get some feedback.
So you technically refine the database yourself. Like if it's confidence answer, you rank it like
Yeah.
on a scale of 1 to 10. What is the confidence level?
Yeah.
What is
Yeah, this is an actual just a research. This is not hypothesis because my research is about orchestration, is about agentic AI. This is an agent. So I will use this agent with my actual orchestration so that it can also connect you to.
And I think it's more of an ontology question. When you say agentic, that agency translate to autonomous or translate to doing a work as an agent of something else. So that agency, it's like automation or the agency is doing work on behalf of someone else.
If you say agent, that works on particular things, particular area. But if you say agentic AI, that refers to autonomous AI. So
Okay.
that works differently. So we are not building agent, we are building agentic AI so that it can orchestrate with multiple AI agents, it can get feedback and it can use the knowledge for the next step.
And one last question, it's generic enough to be implemented in different fields like teaching physics, mathematics, engineering.
Yeah, so it's possible. Currently, I'm focusing on the mathematics questions and multiple choice questions. But in future, I will use this for general purpose. And later it's possible because here I'm using different LLMs that helps me to identify student cues. And if it matches with my predefined cues, then it generates some responses to the student so that it can confirm student is actually understood this or not. So I'm using here LLM, so it's possible.
Amazing work, well done.
Thank you so much.
Okay. So I think he also has a question. But very first of all, compliments for a good presentation. Since you're doing your PhD, I think that the models which you have used, you said that there were some limitations, and then you were highlighting those limitations and trying to find the solutions. So have you applied it, or it's still in the at the conventional stage only?
No,
You have
applied
tested?
this. Yeah, I have used different GPT models. So I've used here LLM 3.5 W here.
Okay.
So that I can test the model in a rule-based system, in a like LLM system, and as a human reviewer, so that I can later confirm like which is best to identify student cues.
But will you be able to use them into the liberal arts also, or only towards the STEM programs?
I have currently I have a plan to use this system for K to 12 students.
Okay.
So later on, I will think about university or graduate level because graduation is the broad level. So I have fixed syllabus for K to 12.
Okay.
So not the university level. So my current project is based on K to 12.
Okay, but have you approached industry also who can?
Yeah, we are collaborating with Reditech Technology. They are also working with these projects, so
Okay.
we can collaborate, and they are in advanced level. So in future, we can implement it not only in education sector, in other sector, because agentic AI is a new concept.
Okay. Yeah. Give your proposals to us also. Yeah. Yeah. Okay. Yeah, thank you.
Finally, yeah, I want to ask you about LM that you said, large language models that you use. So basically, you connect your software, your agent to ChatGPT, other LMs, and how confident are you? Because many large, they're fairly good, but their response is fairly good, but they also make mistakes. And sometimes when they don't know the answer, they just go in different directions. How does your agent figure out, when to stop the large language model? And
Thank you. Basically, I also know about LLM's limitations because I did my master research also on cybersecurity that was also based on LLMs and other things. So here I don't rely on the LLMs only. So I have some predefined cues. So at first, based on the student answer, I have to identify which cues is this. Student is frustrated, confident, overconfident. So later I have to identify these cues with LLMs. So I'm not only relying on LLMs, I have human reviewer also. So I'm checking with human reviewer and LLMs to identify which one is best, which one is actually identifying properly. So here you can see in my table, I have 3 different categories for identification: LLM, auto tutor, and another one is human. So auto tutor is basically rule-based system. I have rule-based system, I have LLM-based system, I have human reviewer. Because currently LLM has lots of issues with hallucination and other problems. So I cannot rely on LLMs. So this is the reason I'm testing this in different way. In future, I will include different LLMs also, like Gemini and other Cloud A, so that I can compare and say which one is best. But currently, GPT is
Yes.
best.
Yeah, thank you.
Thank you so much.
Who's next?
Requesting you for the keynote.
Oh, that would be me?
Yeah,
All right.
the key
Okay.
speech.
Easy, I can do it.
Yeah. Before we continue with the more presentation from the University of Canberra, I'm requesting Professor Payam to have his keynote speech, please, on the dais. Thank you so much.
Thank you. All right. I think I should welcome everyone on behalf of Western Sydney University to our beautiful campus here. Look, we have this tradition of acknowledging the traditional owners of the lands that we conduct our businesses. So I use this opportunity to also thank the original Darug people of which technically belongs to the area that our campus is located. And I also appreciate the guardianship in the past, present, and definitely working towards future. A quick introduction: I'm Associate Dean International in the School of Engineering Design and Built Environment, so I take care of our international portfolio. I had the honor of doing this service for the past 7 years, actually. So hopefully I may retire, step down by the end of this year and focus more on some other works that I'm delivering. But again, this is an amazing opportunity to have you all in this beautiful campus. What I'm going to talk to you about, my background is, I have to change the slides as well. My background is, let me stop sharing. Sorry, I should have set up the presentation first before jumping into the talk. So I go to Zoom, I share. I'll probably share the screen to be easier. Okay. Then I put it on full mode. No. Why it's not showing up? Sorry, let me fix this. Will I fix this? Okay, hopefully it's showing up now. Still not okay. All right. So I'm associate professor of building surveying. And I'm also a lawyer. So I practice as a construction lawyer. So it make you may wonder what I'm doing here. And I try to explain why this particular project covers everything that was aimed by the conference. It has computational engineering in it. It has a lot of sensing in it, and it also talks to management. This particular project, non-destructive digging in asbestos contaminated soil, it's a $800,000 project funded by New South Wales, SafeWork New South Wales. I unfortunately ended up leading this project on my own. So the team was only me, which is very unusual in academic environment. But there is a longer story behind it, how I ended up only doing that on my own. I think the highlight is the way we use sensing to impact policy, to change regulation. And this is a brilliant example of how we can rely on sensory data to touch a very sensitive topic, as being asbestos, and to inform the regulator to revisit their regulatory requirement. Another interesting thing with this presentation that many of you from data science background may not be familiar with, be unusual. You usually deal with big data. The problem we had here was scarce data. We only collected 19 data points, okay? And believe it or not, before this, I didn't know that there is a whole realm of statistics around scarce data. So I learned something new through this project as well. But to extract meaningful inferences from limited data sets, that was a brilliant, very big challenge that I have to deal with, and I learned a lot actually. So each data point cost us around $50,000. And that's why working with asbestos in general is very expensive. This is the first field experiments in, so far as I know, in the world, in real field experiment in 20 years' time. The very last series of field experiments was conducted in Netherlands. So what we did, I just don't bother you with the details. There are different techniques for digging, and recently non-destructive digging, when rather than using physical force, you use a high pressure jet, it can be air or water, to break down the soil, and then you suck the slurry in. It's brilliant. It's easy to control. You can dig everywhere you like with high precision, specifically if you have underground utility. It's an amazing construction excavation technique. If you've been to any construction site and you have excavation, you would know that in Sydney particularly, underground utilities are always a mess. Even when you have plans, when you borrow the plans from Sydney Water, from different utility organization, when you dig, underground is completely different story. So non-destructive digging is an amazing solution for digging around underground utilities in confined spaces when you can't really access with a truck or a excavator, you have to crane them. You use this. But another problem so industry really wants to do it. But another problem we have, technically everywhere in Sydney you dig, specifically where you have older houses, you find asbestos. Australia and Canada were the biggest miner and user of asbestos in 20th century. So we have a big unfortunate heritage of asbestos in Australia. James Hardy, the building material company that was in charge of this, actually their asbestos operation went bankrupt. They established a fund. In 2003, Australia banned the entire use of asbestos. A fund was established in 2024. $150 million was claimed for compensation from that funding. So you can guess how big the problem is. And that's why it's a very sensitive topic in Australia, and Safe Work in particular is very, very cautious about it. That's why we have a regulatory ban on use of high pressure jets on asbestos contaminated soil. That brilliant digging solution, you can't use it at all. So that's what triggered this research, to collect data that would convince Safe Work. And when I say Safe Work, in this case, the minister himself was supposed to be convinced. So all of you have led externally funded contracting research. This one, 20 different experts reviewed my report. And you can guess how sensitive that matter is. Still, the minister wasn't confident enough to sign it right away. I was unfortunate as well. Exactly the same time we published the result, there was the outbreak of, I'm not sure if you remember, the asbestos in garden mulches. Many different parks in Sydney, one contractor spread asbestos everywhere, which again remind Sydney, New South Wales government how serious that matter is. And unfortunately, it impacted the implementation of the work as well. I don't bother you with the details of the work itself. The research design, you will see that we have a range of sensors that we use, air monitoring. And that reminds us, I was thinking last night about talking to you. All of you are used to digital sensors nowadays, or a piece of semiconductors. We've heard the first presentation, amazing sensors. Air monitor is 100% manual sensors. You have a pump, you put a filter on top of it, you suck air in, and then you take that filter, put it on underneath a microscope, and count the fibers one by one. So it's I think, and the most effective tool that we had for this study. We used other sensors, but I just again another reminder for all of us that in the world of digital transformation, still fairly analog sensors are very useful and helps us a lot. To the opposite was dust tracker. Dust tracker is fully automated digital sensor that bring in dust, count the particles. The problem with dust tracker is that it cannot differentiate between asbestos and other fibers. So was good eventually for us because we didn't find any asbestos whatsoever, any fiber whatsoever. So that helps us validate. We had a slow motion camera, and I tell you why we used it. We used it to understand the splatter, how the splatter would grow, because the asbestos itself wasn't the only issue. Cross-contamination was also an issue. 4,000 frames per second. What do we call it? A high resolution. And you can do the math. Each frame is 1 point something megabytes. 4,000 of them per second. It's like a huge amount of data. And there aren't enough cables, good enough cables that enable you transfer that. So I only had to use mounted memories, which only gave me limited time to record it. So we had to be very careful, selective with the actual timing of the recording and things like that. The analysis itself needed a really high computational power. Another funny story, when I told Western Sydney that I need a gaming laptop, not because of the gaming purposes, because of the computational power, it was rejected immediately. So they didn't let me buy it. I had to be, funny enough, I had to find a way to convince them renaming. Eventually, they didn't let me buy the brand I wanted. They made me buy Dell, because apparently Dell has a contract with Western Sydney to like, I can nag about it for ages, to sell us whatever product available they have available. But anyway, funny story, we did the analysis. So far as related to this conference, this is the, oh, it's not, but it's moving. Yeah. This is the where we did the data. We first assembled a secured, safe, contained space, because we were not sure at the beginning. The hypothesis, let me tell you, industry had enough, my industry partners, they had enough good guesses, educated guesses that it is safe. So the hypothesis was that we won't see much asbestos anyway, but we started safe. We did a contained cell, 2 contained cell. We did start the experiments from the inside, and then we moved out. And funny enough, again, I think that's Murphy law, the first spot that we hit, and we did a lot of sampling before for locating that cell. The first spot that we hit a thick layer of asbestos, not just asbestos contaminated soil, a thick layer of asbestos. I should give you a little bit of a story on the site as well. I think that would be, this is in Garside, this is in Parramatta. Top left, That area in 1920s used to be used for landfill. So people used to throw rubbish, and with rubbish comes cockroaches and mice. So what do? You set fire to kill them. So there, and we actually read the Parramatta City Council's minutes from 1920. It was fun to read. To fight the fires, asbestos, the best fire retardant material, cheap, available. Look, asbestos had every single property you want in a good building material. The only problem is that it's carcinogenic. So unfortunately, so they put a lot of asbestos. Later in 1930s, 1940s, the council decided to convert it to a park, but it was a land depression. So they called for neighboring councils to give them building construction waste. And James Hardy being just a few blocks away, their actual manufacturing was the other side of the river. So our campus is on the north of the river. The south of the river was the James Hardy's manufacturing, asbestos manufacturing. So again, they used that opportunity to send them free asbestos waste. And that's where, again, another layer of asbestos was deposited. And no one knew about it up until 2022. What happened? The council decided to install a scoreboard. And they sent a contractor to install this scoreboard. And that's when they realized that, wow, there is another stockpile of asbestos there. And that's where we used it. We used it as an opportunity to use for our study. But the whole remediation work cost city of Parramatta around 6 million, if I'm not mistaken. Normal excavation would have cost them like $600,000, $700,000. You can guess when asbestos is present, how expensive the work would be. So moving to our sensor part, and I'm aware of time as well. So we've collected data. Two things, the friable asbestos. So whatever fibers that would be suspended in the air, we should count them. And then the splatter itself, because cross-contamination would be an issue anyway. And you can see from this data, except the first one, where we hit an actual layer of asbestos rather than asbestos-contaminated soil, the numbers are not even within the sensitivity of the test itself. So when you look at the relevant Australian standard, to have a valid data, you need to have at least 10 fibers per certain, they call it a certain area. I forgot the name of it, but that had a certain name. When you look at with microscope, you need to have at least 10 fibers in certain area to compensate for manufacturing errors, for counting errors, for other fibers other than asbestos. And none of our experiments even reached to that point. So we can say that none of the fiber concentration was even reportable. So there was technically no fiber whatsoever. And the reason is water itself. When we do asbestos work, we use mist to suppress any friable asbestos. This particular excavation, we had water. So the actual excavation point was submerged in water. And we didn't test it, but our hypothesis is that the speed of release of the fibers, it's slower than the effectiveness of the water jet itself to entrap those fibers. And that's why we didn't see any reportable concentration, which resulted in the reporting we provided to the government. A little bit of a slow motion camera at the bottom here, you can see what's happening. And what we did, we tracked every single particle. And here, I shouldn't claim the credit. My postdoc did it. I wouldn't be able to do it. It's beyond my skill set to do that kind of simulation. But the program he did, he captured every frame, you pick different particles, and then you trace them through every single frame. And that's what we eventually found in terms of this expansion of the splatter itself. And then we validated against other source of the data that we have, like normal cameras, visual inspections that we did ourselves, and things like that. That's very similar. Look, during the COVID, everyone was trying to model sneeze, how big the splatter would be, how big the impacted area would be. That's very similar to that concept, that when you hit the ground, how big the splatter would be. Out of that simulation, we've developed a guideline. A rule of thumb, 5 meter was the safe, with the typical pressure, with the typical soil around Sydney, 5 meter. So as long as you have an exclusion zone of 5 meter, you will be safe. We did thermal camera as well. This is for a different use to track, different way of tracking a splatter, because splatter is wet, and in thermal camera, it would be shown colder. So those dark areas are actually wet areas where the splatter are. You can see the different particles. We triangulated the data. They were very consistent with our visual data. We did a factorial analysis eventually in terms of finding out what is effective in terms of shaping the cross-contamination and fiber itself, the presence, release of the fiber. Technically, we studied pressure as independent. We studied the digging pattern as independent factor, and also the truck type, because there are different type of trucks available. And we didn't find any conclusive result that any of those factors are independently responsible for the phenomena we were observing, but a combination of all three were technically what was impact controlling the process. So truck, pressure, and digging pattern together controlled the things. And again, I don't bother you with the details, but just to give you a rule of thumb, 5 meter was what was eventually decided as the safe distance. A lot of practical guidance for the operator that again published in another document, in another guideline. Beside the report, there was a guideline that we developed for the industry. And yeah, I think that's how I don't bother you with the construction side of the regulatory construction requirement of the matter. But in terms of challenges, again, in Sydney, we only have one waste facility in St. Mary's that accept asbestos waste in liquid form. So challenges are not limited, but we've been able to, for example, overcome this one with an on-site cell, containment cell, which took us ages to get approval, but was eventually approved. All right, look, just to conclude, I think that was a good example to show how we in academia can rely on senses to do some sort of engineering, simulation, and computation to convince regulator to relax what they need to do in terms of enabling industry, in terms of empowering what needs to be done. And on that note, again, I thank you so much for the opportunity to talk to you, and would be happy to take questions. Easy ones, please. Our pleasure.
And this is a better understanding about asbestos. It's a very hot topic in the news in the morning, like 76 places have been identified.
Yeah.
Those into schools for this thing. So is it like a fiber that remains there and that it doesn't get destroyed over the time?
Look, asbestos, when it's mined, it's a powder. Okay, so it's a naturally occurring mineral. When it's confined in a matrix, that matrix being concrete, being soil, being anything else, it's safe. So far as it's not disturbed by an impact, it's fully safe. It never releases itself when it's confined in a matrix. The problem arises when you actually manipulate that product, whatever we call it, asbestos containing materials. So far as you manipulate ACMs, that's where it turns into fibers. And because of the size of the fiber, it's very sharp, like a needle, and it remains suspended for up to 24 hours. And it only again becomes problematic if you inhale it. If you eat it, no problem at all. When you inhale it, because of the needle shape, it stucks in the lung. And another problem with asbestos is that the symptoms may not appear within 20 years, 25 years. People might be exposed to it, but within 25 years, they're safe. Suddenly, the symptoms appear. Yeah, but look, the problem is the shape, the actual shape of the fiber, which is like a very sharp needle. It's actually like a needle, but in micrometers, 3 to 5 micrometer wide and 10 to 20 micrometer long.
Just a little bit more for this study. Some of the fibers, like carbon nanotube fibers, and those ones, the reinforced fibers that we use in multiple sheets. So they don't get suspended, although they have a needle-like structure, but they don't get suspended.
To be honest, I don't know the answer to that, but what I know is that the carcinogenic effect of asbestos is because of its shape. So why it is? Look, I don't know much about carbon fibers and other similar material. I don't know if they would be suspended or not, but they may not even be friable. They may remain intact. They may not, when they release, they may not transform into fibers that will be suspended for an extent. But my knowledge is limited on that particular topic. Yeah, sorry about it. Absolutely.
It's a very hot topic, especially last week, camera 76 schools with laws, no state by state with closing the schools and cleaning them up because they just found some sand, some asbestos. But we are told that you just have to be afraid of asbestos because asbestos in the sand is, as you said, it's just there.
Yeah.
As long as you don't touch it, it's not in the air, inhale it, that's safe.
That's safe. I was presenting to a different audience. I presented this work, and there was one to environmental expert, whatever environmental protection expert. One of the colleagues asked me, I haven't shown you, when we go to asbestos contaminated site, we wear those, you look like aliens, you wear like astronauts, you wear those P3 masks with pump. And he asked me, based on this, would you move to a site without protection? Because that was my recommendation. It was confronting question. And I should remind myself I'd actually reminded myself at that moment that I have to trust science. My data shows that it's safe. So I would say to that answer, so far as asbestos is sitting somewhere without any interaction, any physical disturbance to it, so far as it's intact, it's safe, yes. It may not feel safe, but our data shows that it is safe. And it's a very difficult issue indeed, because people have this, including myself, I have that perception that asbestos is dangerous, and I'm not undermining that. It is dangerous, but it can be handled. So if we talk about different approach to risk mitigation, it can definitely be engineered. An engineered solution can, but so far as it's intact in a matrix, confined in a matrix, it's absolutely safe. But don't meddle with it. Don't break it. Thank you so much.
Thank you so much for all the extended support, Professor Payam. It means a lot. And you very well answered. It's a very sensitive topic. It has both pros and cons to it. Thank you once again. Now, hereby, before going ahead with the other set of presenters, my humble request and appreciation to Professor Syed Abbas, who is here with us, and also one of the lead role in the approval of IEEE NSW section. May I please request the audience to have a huge round of applause for him. Can I request you, Professor Abbas, to have a keynote for the audience? Yeah.
Oh, the section. Okay. Good evening, everyone. Good afternoon, everyone. I welcome on behalf of IEEE New South Wales section to this place, and especially at Western Sydney University. Thank you for being valuable partner for a long time with IEEE. We have IEEE student branch in Western Sydney that is pretty active over the time. They host a lot of activities over here. I will just give you a little bit of idea about IEEE New South Wales section. It is one of the largest IEEE sections in Australia, and it's the first one. We have roughly around 3,000 members. We have range of technical chapters starting from electronics, electromagnetics, antennas, microwaves, cybersecurity, electronic devices, computers, related things. So we have those things available on our website. If any of you want to be actively engaged and being supportive to the activities, we provide range of activities for students, young professionals, and our senior and mid-career members. So we have student branches at almost all the universities in New South Wales. We have student branch at Western Sydney University, University of Sydney, UTS, Macquarie University, University of Wollongong, University of New South Wales. So all the universities are there. There are few we are working towards that. And we hope that we will be able to get like our footprint in the universities that are not still being part of the broader community. We will be providing platforms to the students in terms of interaction, in terms of networking, to broaden their spectrum, to get like feedback from the seniors. We also invite distinguished lecturers from different societies. So most of the time, the main society, they fund their travel and they provide them support to go around the world to different countries and different geographical locations to talk on a specific topic. During the COVID, we learned that there are different ways to handle the situation. So at that point, the virtual platform started coming in due to restrictions of not being able to interact in person. So that was a good turning point. A lot of platforms for virtual participation were there. So that provided us with opportunity to have more than certain number of visiting distinguished lecturers. Lectures could be from industry, could be from academic sector, both sides, and they talk on a specific topic. If a society wants to have a particular topic, those topics are normally listed on the society website. So this is one of the aspects we cover. From time to time, we have some events for particularly young professionals because students are transitioning from their academic career to the professional side. We also have women in engineering affinity group with us. They also host a lot of activities to provide platform to the females because the number of females, I believe, they are pretty low as compared to the male numbers we have. Other than this, we provide support to different organizations and conferences around the world. They come to Australia, and Sydney is one of the destinations people are keen to have and host their events. So we provide technical support. In some of the cases, we can be financial sponsors as well, depending upon the arrangement we have. So for this conference, one thing is that what does technical sponsor means? Technical sponsor means that one of the IEEE subsections or sections, you can say that they become a technical sponsor. They take the responsibility along with the conference that we will be looking into conference from the technical side to ensure the quality, and the audits can come anytime. So this is like a very random thing. So the review process is followed for the peer review process. A certain number of reviews are required. Obviously, all the papers they have gone through minimum number. The acceptance criteria and the rates they have been classified, and they are as per the guidelines. Once it's there, the compliance check, the formatting checks, those are performed by the conference people, and then they go to the explorer. So it doesn't end on the last day over here. There's a lot of work in the background that will be happening for the compliance check and other things to ensure the papers are fulfilling the requirements to be online and the standard is maintained. So this is what IEEE do over here. We are approaching towards the end of the year, and we have few more activities to wind up for this year. So I will welcome all of you on behalf of IEEE New South Wales. Those who are traveling from outside Sydney or from overseas, enjoy the beautiful places in Sydney. And I believe that will be a memorable journey for you. Okay, thank you. Thanks a lot.
Thank you, Professor Sayed. That means a lot because the entire review process has been keenly done, and there were set up reviewers across the globe. So, to quickly mention, within the review process, there were reviewers from the US, Canada, Singapore, UK, Tashkent, Dubai, and certainly Australia. And as you said, very well said, that the journey begins after the conference is held. So the major part of again having a micromanagement of the task till the time they are finally published is the main job of the entire conference team. But thank you once again to all the speakers, presenters, and we have yet another set of paper presenters who are online. Quickly to mention that we have people like Chief Information Officer from the Banking Labs Incorporation Canada, people from Infosys US, and many other industry people also who have keenly submitted their paper in this conference. So there are 7 authors who are currently online, as you can see, from USA and Canada as well. Their presentation we would continue. And meanwhile, may I please, for the inaugural ceremony, I'm requesting our Honorable Group Vice Chancellor, Professor Gurinder Singh, sir, to kindly inaugurate the session formally. Thank you so much.
Some days are historical. They are not only important, but they bring a lot of energy, they bring a lot of memories, and then they become the part of the history. On behalf of MIT Education Group, which is today one of the largest education groups of the world, I welcome each one of you. I was listening since morning very carefully the presentations, and I must compliment the entire team, and especially IEEE New South Wales and the University of Western Sydney, that the quality of the papers and the way you have supported this conference, tremendous. Give a huge applause to all of them. About MIT Education Group, this was a brainchild of our founder, Dr. Chauhan, who, after spending more than 3 decades in Europe, came back to Asia to create an education group which can create multiple universities. Today, we have got 13 universities in India, which is the largest education portal of India, where you can see more than 250,000 students are studying. We have got universities in Gurugram, Greater Noida, Lucknow, Jaipur, Mumbai, Gwalior, Kolkata, Raipur, Ranchi, Patna, Mohali, Bengaluru, and Hyderabad. 150 institutions and our overseas universities in London. So we became the first Indian education group which has got a university in London. We have got a education institution, 2 institutions in Singapore. So if you happen to be at the Orchard Road in Singapore, and that's the next conference we are organizing in Singapore next week, I'll be flying from here. And then we have got 175 acres campus in New York. We have got a university in Dubai, in Abu Dhabi, in Sharjah, Mauritius, South Africa, Kenya, China, Amsterdam, and San Francisco. 28 schools and preschools, which are one of the very prestigious schools in India and abroad. Under the new education policy, the Prime Minister of India, Narendra Modi ji, wanted that we should be able to bring some of the leading brands of the world to India. And that's the reason that we are traveling from one country to another. So first very huge brand which we brought to India was Harrow Schools. So I think that you may be knowing that Harrow is one of the most prestigious schools in UK, and they now have their fully residential school in Bangalore. Uh, uh, from Australia, we welcome large number of Australian universities. We have seen few Australian universities coming up and opening the campus, including the Western Sydney University, which is one of our partners. But the effort of MIT is to create a sustainable partnership. And we are trying to bring some of the leading universities of Australia to India. I am personally speaking to quite a few universities from Australia to be a part of this ecosystem. I can see large number of our friends who are present here coming with us. Large number of friends who are present here, helping us to strengthen our relationship. I want to acknowledge quite a few of them who are here. The Vice Chancellor of Western Sydney University, who has been a great supporter of this conference, and I know that they are starting their operations from Greater Noida campus, but then we have offered that maybe that we can support them in not only establishing their campus in Greater Noida, but also offering them the infrastructure where they can start up their programs. And we will be working and jointly doing many programs together. Thank you so very much. To the IEEE New South Wales, we will keep on organizing our conferences with you, both here and in other parts of the world. As you know, that we are one of the largest collaborators with IEEE. We do conferences across the world with IEEE. We are one of the largest collaborators in New York, where we did a conference in Maine, and then we are organizing another conference in the next summers. All of you from Australia are more than welcome to join us there. We also do with the IEEE Singapore, one of the largest conferences there. And I think that two chapters which IEEE Singapore is opening, one is in China, other is in India, it is with us. So next year we are going to organize it in India. So all of you, you are more than welcome to come to Singapore and also to India as a part of our journey. We are also the largest partner of IEEE in India, where we do number of events with them. And similarly in Dubai, we are doing a large number of events with IEEE. Also can see large number of very senior researchers who are present in this conference, and industry, which is a backbone of the various initiatives we are taking. My appreciation to some of the leading industry leaders and academic leaders who are present here. One is our Professor Masood, who's from the University of Canberra. Give a huge applause to him. I think our friendship goes to more than 2 decades now. And he has been not only supporting our research, one of the very able, I would say, academicians who has been supporting it. Thank you so very much for helping us to do this. My appreciation and respect to Professor Payam Zekwith, who's the Dean of the International School of Engineering, Design and Built Environment of the WCU. Also to Professor Said Abbas, the section chair of IEEE. Give a huge applause to him. I think it's because of your efforts that we have been able to bring this conference here. Our thanks. Please keep on coming to our all conferences. And I would request Professor Shweta that please call him to our next conferences, which we are organizing in February in India. Be our guest. We'll be more than happy to see you as our very esteemed guest. Also to Professor Velayat, who is sitting here, very senior member of IEEE, senior member. And great to see your PhD students presenting paper. I was very impressed by the ones. By the way, I was very impressed by the young one from the University of Sydney who gave the first paper. Normally, you will find that very senior academics, they present their papers, but when you see someone who's very young presenting a paper, and great appreciation to your parents if they are here. Uh, they have gone. So, but please convey our best wishes. But it's very good to see someone at a young age coming amongst the scholars and the senior people, the deans, and giving a presentation. And to all presenters from across the globe, I have given to understand that we got somehow around 602 papers, out of which 193 have been shortlisted to be presented. So my compliments to all researchers. Give a huge applause to all of them. My special compliments to the industry, which has been supporting us. Mr. Vic Bansal, who's the founder and CEO of the Bodil, Sydney, Australia. Give a huge applause to him. Thank you so very much for supporting this conference and keep on coming and keep on supporting it. But on behalf of MIT, on behalf of IEEE, Western Sydney, thankful to you for supporting it. Also to Mr. Anthony Vipin, CEO of the Lotus Energy of Australia, for supporting this event. I think that whatever we do in all the academic institutions and the universities, we try to do for the industry. And when we see the support from the industry coming up, I think that the technologies which we are creating, it is for you. As we say that we need to obsolete ourselves. If we will not, then someone else will. So good to see that industry is supporting it, but thank you so very much. Also, thanks to Mr. Keith Sherigan, trusted advisor and trusted advisory services for enabling and embedding AI and director ADT. Mr. Palash Nandi, who's the CEO of Ligrent Australia, who has joined us offline. Mr. Ben Jones, the CEO of the Lotus Energy. Dr. Krishna, the Chief Innovation Officer of the Banking Labs, Canada Department of Biological Sciences. Mr. Rajendra, who is the Assistant Vice President of the US Bank. Mr. Arun Kumar Yadav, Senior Finance Officer, Leader and Expert, AI, ERP and FinTech of HCL Technology. Mr. Ankur Tiwari, please give an applause to him, from the AI-powered content management architect Jagdish, Mr. Jagdish, who is from the Arabia Enterprise, who has joined us from Atlanta, USA. Mr. Arendra, who is the head of the Euro Technology, again from USA. Mr. Krishna Mola, Principal Software Engineer, who is joining us from the New Credit Union USA. Mr. Dharnesha Narpasa, who is the Senior Network Architect from the Texas, USA, and many others who are helping us to create a history in Australia and other parts of the world. As we say, that for every conference, the most important are the researchers. So I was just looking at the quality of the papers which we have. So in all the 602, I think that we have been able to shortlist only 193. But all those who have contributed, our compliments to them. Your papers were really good, but then we have our own system of reviewing it and then sending the remarks. But please improve your papers, and you can send us. And I promise you that maybe in the next few conferences, we are going to take it. Once again, thank you very much. I also want to acknowledge large number of our colleagues. Dr. Shweta, who is here, I think that a huge applause to you for your efforts from the last 1 year. She has been helping, working very, very hard. And the research team back in India and in other parts of the world who have been helping us quite a lot. Give a huge applause to all of them. Dr. Sohini, if you can, she's now in Australia, but I owe a lot of things. I remember that I flew from, I think I was coming from Europe at that time, and I flew to New York, and she was looking at IEEE events and conferences in the US. And I don't know that how many of you know about it, but for the vegetarians, yellow dal is a treat. So she cooked that yellow dal and she treated, so that I still owe that to you. But wherever you are, we feel so proud on your research work, which you are very ably doing. Our International Affairs Division, which has been working day and night, give a huge applause to them. It's, I think, whole night they have been working for quite a lot, and three of our very distinguished colleagues, Vivek, and Ravneet, and of course my own Marut, who has been working day and night to organize this conference. Our own secretariat, which has been helping, Ms. Soji, Ms. Ayushi, Ms. Sheetal, Ms. Simran, and all those who have been contributing. I can see some very young publishers here, uh, Upasna and Simran from the Ball Pen Publications. Thank you for flying from India. And I know that your publication is new and then you are trying to create something like Springer. By the way, Springer is supporting this, but maybe that in the times to come, you will have your own company. It's always good to see a youngster coming up and trying to create a history. Once again, on behalf of our founder, Dr. Chauhan, on behalf of our chancellor, Dr. Atul Chauhan, we have got 13 vice chancellors. So, on behalf of all the 13 vice chancellors, on my own behalf as a group vice chancellor of the entire group, on behalf of IEEE, on behalf of Western Sydney University, and all Australian universities who are trying to have very good relationships with us, we welcome you. But for all Australian universities who want to create a campus, please treat Amity as your home. We know that about 15 of Australian universities, they want to come up, they want to establish their universities. So whatever support is required from our end, we will be more than happy to extend. And we know that it's going to be a very sustainable partnership. I can see also large number of our alumni sitting here from Monash, from University of Melbourne, from University of Sydney, and also later on in the alumni session, large number of our alumni who are going to participate. Once again, thank you very much. It was such a pleasure to speak in front of you.
I'm highly indebted to all the authors, to all the esteemed speakers, and nonetheless, our respected vice
I think that there was one lady who was working day and night to integrate industry. So I would like to recognize the efforts of Ms. Flossie Gupta, who is there. I could see her face on the screen. But well done, Flossie. I think that almost whole night you were working from and have been able to integrate industry. We recognize and appreciate your efforts. Thank you.
Thank you so much once again to all the extended efforts put by the team, Dr. Prateek, Dr. Pratiman sir, Mr. Marut, and everyone in the team who has been continuously working day and night to make this conference a huge success. And certainly need not to mention the research team, who is the backbone of the entire IEEE successful conference. May I please go ahead with the award session of this conference, and then we will continue with the paper presentation and the alumni session, which will. So I would also request Professor Masood, who is from University of Canberra, to kindly come over the stage to address the audience, please.
Right. Very welcome to the conference that's organized by our friends from Amity University Group. I'm very pleased to see you back in Australia. We met last year again in Monash, and next trip or next stop would be at the University of Canberra, and we will be more than happy to welcome you to Canberra and also Australian National University. My talk is going to be very brief. I prepared some presentation, and then I was. Yeah. It is opening. Otherwise, I have another presentation here. My presentation is also as deadly as Python. but not about asbestos. It's about what's happening in our household as we get older on human fall detections, preventions, and recovery.
Can we, is it on this stick? Can I use this?
Thank you very much.
Use this one. No.
Yes, sure. I just prepared very short presentation, but then I added a few bits and pieces as I was sitting and listening.
To see if it identifies.
If it is not working, I will use the board presentation.
Identify quickly. Sorry, give me one second.
That's okay.
Let me connect it directly. Yeah. Which one? 25.
25, yes. Is it coming? Or
It's coming.
No.
Press escape T to cancel opening.
There we go. So perfect.
Now share it so people would be able to see.
Thank you.
Yeah.
Just move with the.
Yeah. Just click and
Yes, sure. Perfect.
you can scroll as well.
Well, thank you very much. Thank you again and being patient. Just the talk is going to be very basic, but I'll go through some developments that we've done and cost reductions in developing sensors. We work on hardware and software, both at the University of Canberra, and also my cooperations with the Computational in Adelaide. So, and our groups. The topic is the development of devices using artificial intelligence for applications in healthcare. Basically, the topic of this talk is on human fall, but we're basically doing several sensors, and we use this, believe it or not, the same sensors that we have used in fall detections in a sport now, and for recording athletes and sports people's movements, especially in cricket. And I'm learning a lot about cricket. So although I still am improving, I'm not a champion as yet. So what I want to talk about basically on fall detections, preventions, gait analysis, and recovery. And please stop me wherever you have a question. So basically the elderly falls are growing as we're growing older and as we have older people in our society. World Health Organizations identified the human fall or elderly falls as second leading cause of unintentional and accidental death in the world. And as I said, we're doing some work at the moment and some sharing of knowledge with Amity Group of universities on this research, and I'm fairly confident that that would be a very successful venture for both universities in Australia and also India, and also in your Dubai campus. So we have used some machine learnings just as a flavor to this talk, and I'll show you the results of machine learnings on human fall detections, and of course the percentage of successful identifications of falls is over 99%. So basically, we are fairly confidently what I have done. And can you see my screen? Or no? Sorry, Payam. Basically, it is very easy to detect falls and using sensors, using cameras. The issue is when a fall happens, that's where the disaster starts for whoever had a fall in your life. I see all young people here, but for elderly, that's not as present activity that will follow after a fall. So the difference between also the male and female is not much. It doesn't help you if you're male or female. Fall happens for everyone. And the statistics is 1 in 3 people on age 65 and over will have a fall. And if the chance of survival is less than 40%, yes, you will see many people that have fallen and still are around, but many people don't survive after the first fall. The issue with the fall is that after the first fall, the second fall follows and things get worse. So you don't get better, you will. Medication we use, vision.
Sorry, not sure
why
it's disconnected.
That's fine. That's fine. I'll just continue. What I will show you is a couple of sensors that we have used and also a couple of sensors that we have developed. The issue with the fall is once somebody falls, what happens? If you're lucky, you just get up and start walking again. In many occasions, that's not the case. If you're lucky that you fall and it doesn't cause major injuries, such as brain, head injuries, and it's just more of the bones issues and breakage of ribs, etc. That follows up with weeks and months of staying in a hospital and rehabilitations afterwards that can take up to a year. The cost is very high. The cost is very high. I am your plan.
Yeah, sorry.
No,
That was lucky.
I don't know what I have done. So here it is. You can see coming back to the early, beginning of my talk. You can see the graph of people that have got a fall and their age. As you get older, so the chance becomes worse. The chance of getting falling becomes worse and worse. So here's for male, female, and we just put a person, and you can see if you survive over 85, it doesn't really matter you have a fall or not, because you really are doing perfectly, and especially after 85, the chance of surviving a fall is very, very low, unfortunately. So here it is, a couple of statistics. As I said, the value that's shown here, 600 million, it's actually refers to back to something like 12 years ago in Australia. So the value is much higher now. It's not just because of the inflations and the cost of living. It's just that we're getting older. We have more older people at the moment. So there are two things that we have to identify for fall detection is that you're just doing your activities of daily life, whatever you're doing, walking, making your cup of tea, sitting, lying down, and then, a fall that you have to identify. And that's why it's very easy to identify, actually, falls. It's not difficult. It doesn't matter which sensor you use. You use cameras or just the sensors that people wear, wearable sensors, your watch, sensors in your shoes that we have developed. And here it is, you can see, I'm not sure you can see, it's, you're fantastic, I wouldn't be able to live without you. Thank you very much. You're fantastic. So here it is, very interesting. And I try to be quick. If you look at the diagram, that just gives you very good indications of what the future holds for many of us. So a fall happens. The next thing is that people end up in hospitals or go through extensive medical support. What happens to the person is two things. One is physical. The second thing is mental. And the issue with the mental actually is much more difficult to fix, because once you had a fall in old age, then you have a fear of falling again. And that causes people to reduce your activity. So the inactivity, not moving a lot, not continuing with your yoga classes or aqua aerobics classes or other activities that you do. This inactivity causes basically decreases in the bone and muscle, mass, and very quickly, unbelievable. And then the next thing is the person has got the worst balance because you just are more careful, you're not moving, and you're losing more muscles, and you lose more balance. And again, that causes the issue of falling again. And then, nobody wants to have a second fall. After, if you have got someone at home and you've seen it, and that happened to me in 2019, with my mother had a fall in the bedroom of her house, which basically ended up 3 months of rehabilitations in the hospital, and then another 6 months for her to learn to walk again, and then drive again, and etc. Not only the loss of independence, the mental part of it is very, very difficult for older people. So here it is, very simple. You can see the diagram above. Figure 3, the activities of daily life. Very normal activities, moving around, and this is our sensors showing people are moving. And then the second and the figure number 4, just below, you can see a fall happen. So that's why it's so easy to detect falls. That's why you get 99% of accurately predicting your fall. So here it is, your activities, and then fall happens, and then the activities stops. Sudden movement, and so that's why you don't need them to use machine learning to do this kind of tasks. Very easy to predict from the data. So we just used a couple of data sets. That goes back to 5 years ago, and we did some pre-processing of the data that's available for any of the dear students that are here and participants that are here. That want to do any work in the fall detections. We've got also released our own data sets, and you can write to me, and I can provide you not only with the data sets but also with the programs that you can use for machine learning and experimentations in the fall detections. So 6 machine learning techniques were used, and as you can see, there's nothing to show, and you just here. You can see, we just accurately 100% of the time. It's 99.6, 98.9, basically 99.9%. You can predict accurately that the person falls. But the issue is, what happens when the person falls? What can you do before the person falls? So we have developed the sensors that can tell us. I can also buy watches, etc. But we have got sensors that we have embedded in the shoes. You have got the one that embedded in the clothing, and it's useful actually. We are trying some experiments in hospitals and rehabilitations for people that had falls, and so carry those. So for quick emergency response, so you can basically almost 100% be sure when a person falls, it. Not only that, you can also use cameras, and cameras are big issues because you all are worried about our privacy and security, but wherever we go, there's cameras. Here you're sitting, there are cameras, and monitoring you. So here it is the issue with the fall preventions. That's really how we can solve some of the issues in this area, not just by predicting falls, because that's too late after the fall. If the person survives, it's just very expensive and very difficult tasks in front of the person and whoever is supporting that person. So here are the issues that you may have. Of course, the first thing is the age, vision loss, bad balance, basically, and then the other bits and pieces that follows if with the fall, with anxieties, floor types is an issue, medications and mix of medications as we get older cause some dizziness and vision problems, and people can fall. And muscle loss is another thing that we cannot avoid it, although exercise is a fantastic thing to do. Continue if you're doing yoga with your yoga. And then cognitive functions and poor reaction times. They're the issues, the factors that impacting people's fall. Please stop me if I'm going overboard with this. So we, at the beginning, this is going back to 4 or 5 years ago, we started using on-shelf sensors. This is Activity from UK, fairly cheap, a couple of $100. I think it's reduced now to around 200 now, Australian. And that can be embedded in your watch, in your or on your wrist. in your clothing, etc. And basically, it just measures movements, and basically, you can also relay that, onto your mobile phone through the apps that we have developed. So the other issue with the other things that you can do with this sensors is to predict or to monitor the gait and movements of the people, so you can figure out if your walking behaviors or walking behavior of the person has changed. And that's one research area with a couple of my PhD students that are looking into gaits and how people's movements changes over the time. The issue is that for many people that's a very slow process, and they don't realize. You'll have a knee and hips problem, and your walking becomes worse and worse. And if you have got older persons in your family, or the person who has got problem with the knees and hips, you'll notice that things get worse. And because it's over the time, people don't realize it till it gets really bad, and people cannot move. So this gait issues is another problem with the force. So many of you have used OpenCV and YOLO, available as open source, and they're actually very, very accurate, very good. For example, with OpenCV, we did another project where you have got the camera, and the camera is facing in the camera facing you, or facing a room that you're in, and basically it can take your movements, and then it puts 16 points in different parts of your body, and as you move that can follow you. So we divided these movements into upper, lower body, side movements, etc., and they're very accurate. So here it is. Actually, it's outside. And what's very interesting is the accuracy of these systems. It's open source. Just with the normal camera, I think around $150, $170 that we have used. That's right outside in the garden behind our labs at the University of Canberra, and the person is project students that's just walking, and you can see the points on the side angles. This is just looking at the side, not the straight away facing. The camera doesn't have to be facing the person. And this project was on, how can we improve the privacy of the person? So what we are interested in those points of the body to, predicts the falls and the movements and the gaits changes, etc. We don't need to have actually to store the video of the person. You store just the data on the body, and you can see on the right-hand side of your screen the data that relates to the nose, left knee, left eye, right eye, left ear, right ear, elbow, etc. You can see that. And actually, we can reconstruct from this data the skeletons of the person, not the pictures. So this is one way that we can convince people, yes, the camera is facing you, but we're not recording you. We're just actually recording you, but we're just recording the data sets that we need. And that can be used actually for monitoring the gaits of the people. The issue with Australia, I think, many countries around the world, is we don't have enough people to look after the elderly. It's very costly. So maybe a camera that just doesn't take pictures of the people, or don't take the video of the person, just takes the points on the body and then observes the points and gives feedback to your GP or practitioners that wants to know how you're walking and moving, and also monitoring the movement of the people. We're just doing it in rehabilitation facilities. How many movements the person does, how many times they move their hands up and down, or legs, or hips, or head, or or neck. So that can be used for gait analysis. Here it is again. We just did it purposely on the side angle, so you can see that the camera doesn't have to face you to be able to get the data. The next thing is, at the moment, doctors in aged care also just perform certain tests, and we're working with them. And the test could be, putting a sensor in your shoes, and here it is, the sensor in the shoe actually connected to the cable. That's about 3 years ago. Now we have got it wireless. And the sensors just goes in as insole inside your shoe and just relays the data. And here it is, the pressure points. If any of you have got diabetics, probably have done this this test with your GP or practitioner. If you haven't done it, it's a good idea to do it because you can see here the pressure points of the foot, left and right foot on the person. And basically you can relate it to the balance of the person. And that's used very much for diabetics. Here it is, again, another educational graph that shows you the left-right foot movement, and the graph of it, just on a normal, almost normal person. Yes, I will be finishing in a minute, sorry. And here it is, the collection of the data, as you can see, as the person moves around. There we go, he should be moving. Sure what's happening, but you can see the pressure points that we calculate for the balance of the person. So these are the things that we are preparing now because fall detection is not actually useful. We don't find fall detections to be useful other than in certain situations where the person falls and cannot move. And we've heard of stories of people falling at home and being at home for a day or two before they're found on the floor and cannot move. So here is the exercises that they give them or for balancing or before or after the falls. There you go. Here it is one of our fantastic students that decided not to continue and went for a $150,000 job. So I couldn't offer him more than that as a scholarship. So I think all of us have got the same problem. So he's a very clever person and is just working for the industry. Here it is again, a couple of students doing the balance test. This is what happens in nursing homes. We're just automating it through our sensors. Everything helps and everything works. Here are the sensors that you can see here just on the floor. These are the ones that we purchased, and they're actually fairly expensive. Now we built them. We just designed them, and the prototyping in China. Hopefully, we will keep the intellectual properties because here it is the assessment test that they do in the hospitals. And as I said, you can basically do it with our system. So finally, thank you for listening to me. Keep exercising, keep your balance, stay away from falling, and hopefully you will have a very nice life and not ending up in the hospital. So these are the projects that we are doing, and we're basically collaborating with Spew Research, is actually in Noida, and for a couple of project students they have used, and I'm not sure it's going to go for a PhD, etc. So hopefully when you're in Canberra as our guest, I can give you some sensors to take home with some of our devices. We're planning also to start working with the Indian companies to produce our sensors rather than sending them to India. So this is all I have to say. Keep well, stay well, and thank you for listening to me. I know it's lunchtime or whatever it is. Thank you for listening to me.
Thank you so much, Professor Masood. Very thoughtful of you to share about the utility of the fall prevention and also your extended help to the internships in India. Thank you so much once again. Going forward, may I please invite Mr. Vik Bansal, who is the CEO and MD of the Boral Group. Thank you so much for your presence. May I please request the audience for a huge round of applause.
Thank you. I cannot match what you just presented, of course. That was intellectually very stimulating. My brief is today, as I understand, is to talk about my own journey. I think that's the brief. Is that right? That's what I'm supposed to do. So first of all, good afternoon, everyone. Vice Chancellor, faculty members, students, and distinguished guests. Thank you for inviting me to speak today at this Amity University function here in your beautiful Sydney. It's truly a pleasure to see Amity. I've heard a lot about this university, of course, with its roots in my hometown in India, flourishing here in Australia. So congratulations. India's intellectual depth and Australia's global perspective is probably what's making this successful. I'd like to share briefly a few reflections that connected both countries, both worlds, and both journeys for me. Through the lens of my experience, I'll talk about my own journey from India to Australia, how my engineering background shaped my leadership. I was never good enough to become a PhD or anything, but I just went into the industry early, as your young man did. And the lessons I've learned about success and leadership that might help you as you embark on all your own careers. So I was born in Karnal. I'm sure you would know a place in Karnal, a small but proud city in northern India, north of New Delhi, known for its hardworking professionals, people, and its strong education values. Growing up, these were high expectation of academic performance, as all of you Indians would know. Your parents don't let you go. I was fascinated by how things worked, machines, systems, industries, and that curiosity led me to do my engineering from bachelor's in National Institute of Technology, Kurukshetra. Like many of you, I saw education not as a destination, but as a passport, a way to see the world and expand my possibilities. When I first came to Australia in early 1990s, I had no family connections, no roadmap, just pure ambition, curiosity, and a strong work ethic. Those early years, which coincided with recession here in Australia, people who were here in 1990s would remember it was quite a big recession, were challenging. New culture, new expectations, a new way of doing business. There was a lot of learning, and in some cases, relearning that occurred. I remember buying a banana for $1 or 90 cents, and I was trying to convert that into Indian rupees, and I figured out that it was a very expensive banana. There was plenty of rejection letters, but one thing was clear. Australia rewards merit, effort, and integrity. From those early days, I've gone on and had the privilege over the years to leading large and diverse organizations as a CEO of Cleanaway, Infrabill, and now Boral, which is Australia's largest construction material company, each with a strong focus on industry, sustainability, and digital transformation. But through all of it, I've never forgotten where I came from. My Indian roots, discipline, respect, and perseverance, combined with Australia's openness and pragmatism and sense of fairness, have been a very powerful combination for me. When people ask me what prepared me for leadership, I don't say an MBA or a management course. I always say engineering. Engineering teaches you how to think analytically. It trains you to take complex problems, break them down, and rebuild them into something better, which we just saw. That mindset is invaluable in leadership. Whether you're designing a bridge or leading a company, the principles are exactly the same. Understand the system, identify what's not working, design a better solution, and execute it with passion. Engineering also teaches humility. It reminds you that even the most elegant design can fail if you ignore the details or the people who bring it to life. Let's step back for a moment and look at the bigger picture. We are living through a remarkable chapter in the relationship between India and Australia. What started as a trade and education link has evolved into a strategic partnership built on trust, talent, and technology. I'm a board member of a Center of Australia-India Relationship, and I know how much work is going on in the background. Today, India is one of the world's fastest growing economies, driven by youth, innovation, and digital ambition. Australia brings world-class expertise in governance, sustainability, and advanced industries. Together, these two countries can create powerful new opportunities in sustainable manufacturing and logistics, circular economy and clean energy, digital transformation, and AI. The students here today are uniquely positioned to bridge this partnership. I don't think so you appreciate how lucky you are. You understand both worlds. You can combine Indian ingenuity, or as we call jugaad, with Australian pragmatism, and that is unbeatable mix if you apply it. Let me share a few lessons from my own leadership journey. Number one, always lead with clarity. Be purposeful. People follow vision, not titles. Have a clear values set and don't compromise them. Maintain your integrity always. Embrace change. The future is not something that happens to us, it is something you create. Peter Drucker said, the best way to predict the future is to create it yourself. Change is one thing which is always going to be constant. Build resilience. Stay steady and optimistic when things get tough. How you react to challenges in your working or personal life influences those around you. Calmness under pressure, which is not necessarily a trait we have as Indians, can help install confidence in your colleagues and provide them with stability. Nelson Mandela once said, "Do not judge me by my success, judge me by how many times I fell down and got back again." Stay humble. Leadership is about lifting others, always. Be mindful of your mean, say, do ratio, which is my favorite thing. Be accountable and follow through. It always you say what you mean and I do what you say. I judge people by that and have never failed me. Never stop learning. Every success and setback teaches you something new. A good leader will continue to learn and grow and be humble enough not to just realize this. So to all the Amity students here today, remember that your education is your foundation, but your attitude is your launchpad. You're part of something special. You're lucky. The next generation of Indians have right, very, very good future in front of you. So as you step forward, build, lead, and inspire, not just for yourself, but for the partnership between India and Australia and all the future it brings to you. I thank you again. Appreciate it.
That was quite inspirational. Thank you so much, Mr. Vic. It was very inspirational and a very good thought. As a good thought leader, you have inspired the students, sharing your journey. May I please request Mr. Anthony Vipon, CEO, Lotus Energy and Chorus Group, to kindly address the audience.
Thank you, everyone. And I just said to my son sitting next to me, I said, I hope I'm not next, because that was an excellent speech. That was very inspiring. Firstly, I'd like to thank Western Sydney University and, of course, Amity Education Group and IEEE for the invitation. I'm very humbled to be invited up here. As someone from industry, I thought what I'd do is share a little bit of a story and encourage all of the students that are doing their wonderful work out there to stay inspired, to keep working towards what you're doing. And really, my message is be brave in your journey. And I'm going to share a little bit about my journey and where I came from. So my background is I'm actually an electrician, so I've never been as well educated as all the people in this room. And it's unbelievably impressive to see the work that you do and the importance of it. And at the core of all of those pieces of work that you're doing, the one thing that's outstanding is that you've identified a very large problem. You've identified something from your field of expertise that you're perhaps passionate about, and that's very, very important. So my background being an electrician, I started working with my father in 1991 on solar. So we started installing solar in Australia, battery off-grid systems, and we became quite a large company, and we're quite fortunate. I've worked around most parts of the world and substantially in India, across many states, and I'll sort of lead to that story where the connection with Amity came together. But through that journey, we were installing the systems, and as that progressed, of course, the problem began burgeoning, and that problem being the waste that we were creating. And at the time, we were paying a company in South Australia to recycle for us, and we thought we were wonderful citizens doing the right thing. And we subsequently discovered that, unfortunately, this company that was purporting to be recycling wasn't actually doing the right thing. And through that, of course, we identified a problem, and we started on that journey of going through the research and development and developing a solar recycling facility, which we since established back in 2020. So it was, I know it's only 5 years ago now, but in the terms of solar panel recycling, it was quite adventurous and ahead of its time, so to speak. To put some of this problem in perspective, for the Indian guests listening in, I think by 2050 there's 19,000 kilotons, which will equate to around about, I think if I get my numbers correct, 95 crore solar panels, which is almost an incomprehensible amount of solar panels. And that problem is being addressed by you, by the researchers, the people doing the hard work that actually are solving these problems. So at present, we're working with universities on AI detection of solar panels for testing and repurposing and smart learning, integration of automation and robotics to minimize labor content, improve OH&S situations, air monitoring. There was one of the discussions today, air monitoring for dust particles and potential silicosis and future problems that maybe we haven't even identified yet because it's a new field. And this is an incredibly important topic. Of course, I'm passionate about it. It's my background. That within a solar panel, there's some of the most important critical minerals that are leading to all of the technology that most of us are working on in some way, shape, or form, in silicon, in silver, in copper, in aluminium. These are the four core commodities of all electrical infrastructure. The things that we've done to date and achieved, we've achieved a 98% recovery rate from the solar panels. We've extracted the solar cells. We're now working on, still in R&D, the recovery of the silver. This part's incredibly important again, because what that means is that we can continue to produce solar panels. Many of you wouldn't be aware that there's a global shortfall of silver due to the high production of solar panels. It's consuming roughly 30% of the global mining production just from solar panels. So that urban mining concept of utilizing recycling to recover that material is unbelievably important. One of the big problems, and far less valuable but equally important with a solar panel, is actually, believe it or not, the glass. It sounds very simple. It's a glass product, surely we can recover it. The challenge around a solar panel is it is built to last. We hear of these figures, it can last 20 to 30 years and have these performance levels of low degradation rates, etc. Well, that high quality of manufacturing equally means that it doesn't come apart easily, not dissimilar to a car tire in that same sense. So the glass is bonded to those materials. And one of the projects that we're working on and that we've submitted with our local government here in Australia is an AEA Ignite grant. I hope we're successful because Amity Noida is actually involved in that project. Thank you. And furthermore to that, in recognition of some of the things that we've achieved from these developments and the recoveries, we've been invited to develop a new site in Germany, which we've since signed off on, and that's in planning. And equally, credit again to India is that we've been invited by the Indian government to establish facilities, 5 facilities in India, the first of which will be just north of Patna in Bihar. And I was glad to see that it was one of the locations of Amity for your campuses. But what I do stress is for the students whose papers perhaps weren't chosen today, part of every journey is failure. And it's not failure of making an attempt. Failure is giving up. And the gentleman before speaking about perseverance is one of the key aspects to everything is perseverance. And I encourage you all to be brave in your journey. Choose your topic that you're passionate about. Keep working towards it, and don't lose sight of your goals. And thank you for inviting me to speak. Thank you.
Thank you so much, Ms. Anthony, and great to hear there's so much of integration with the Indian boundaries. Thank you. And thank you for bringing your son, Jacob, along with. That's a delight for all of us. We are going ahead with the conferring of MET Academic and Industry Excellence Award. Here comes the time that we are closely winding up the inaugural session. May I please invite the entire delegate team on the dais, professors, the Group Vice Chancellor, sir, on the dais, and Professor Masood. Our MET feels honored to confer the award to. Yes.
We come in the camera. Yeah, need to come in the camera.
Yes.
Then you need to click.
Hello. Amity University feels honored to confer the award to the esteemed delegates and the invited guests at the inaugural session. May I please invite Professor Payam Sekawat, who is the Associate Dean, International School of Engineering, Design and Built Environment from Western Sydney University. I'm requesting our Honorable Group Vice Chancellor, Amity University, and Professor Masood to kindly confer upon the award. A huge round of applause, please. Thank you. And incredible support from the IEEE NSW Section Chair, Professor Syed Abbas. We cannot thank you enough for all the extended efforts you have leveraged in guiding us and also ensuring that all the micromanagement is done. May I please request you on the dais, please? We are short of words, Professor Syed, to thank you. May I please invite Mr. Vic Bansal, the founder and CEO of Boral Sydney Group Australia. Your cooperation has been extended one. Thank you so much for sharing all the thoughtful inspiration.
Thank you.
May I please call upon Mr. Anthony Vipon, the CEO of Lotus Energy and Codus Group Australia. Can I invite the Jacob, please? This conference has been a beautiful amalgamation from the academia, industry, the scholars, research scholars, paper presenters across the globe. There are total 10 tracks which are running in the hybrid mode in Australia and 9 in India. A big thank you to Mr. Keith Sheringham, who has been a great support to MIT University from quite some time now. He has been visiting to MIT earlier. He is the trusted advisor service on enabling and embedding AI, Director ADT Partners. Thank you so much, Mr. Keith. It's a great delight to have you at the conference. MIT feels honored in conferring the MIT Award to you. Thank you.
Thank you.
Now, may I please invite Mr. Palash Nandi, the CEO of Legrand, Australia. We are proud to have all the industry leaders to be here in the conference, along with the veteran academia support. Thank you for making the conference brighter. Now we confer upon the award to Dr. Masood Mohammadian from University of Canberra. It's your efforts in the conference are incredible. Thank you so much once again. Here we have a set of 7 esteemed speakers and the awardees online from the USA and Canada. And may I please ask Dr. Krishna M. Kowat, the Chief Innovation Officer, the Banking Labs Incorporation Canada, Department of Biological Sciences, University of Alberta, Canada. Thank you so much. He is also one of the paper presenter in the conference who is presenting in the track. Thank you so much. May I please request Dr. Rajendra Shilukala, who is the Vice President, US Bank, USA. Mr. Arun Kumar Yadav, the Senior Finance System Leader and Expert, AI, FinTech, HCL Technologies, USA. Your very beautiful quality paper contribution has been incredible. I really appreciate, and we are indebted from MIT University. Mr. Jagdish Vasanthada, the SAP Ariba Enterprise Architect and Project Delivery Manager, Atlanta, USA. Mr. Arendra Tyagi, Head of Oro Organization Technology, Wells Fargo Bank, USA. Mr. Krishna Mula, the Principal Software Engineer, Navy Federal Credit Union, USA. And Mr. Dharnisha Narasappa, Senior Network Architect, Networks, Austin, Texas, USA.
Thank you very much. I'm
And
honored.
Mr. Shubham Singh.
Thank you very much.
Before we move ahead, a special thanks to Mr. Velayat, who has accompanied Professor Sayed. And we really appreciate that you have brought your PhD scholar along with. May I please request to be here on the dais? Thank you so much for your quality paper and contribution to this IEEE conference. Thank you so much.
2 minutes. Thank you, speech.
Yes. So before I quickly go ahead, I would request the online paper presenter as well as industrialists who are there online to kindly have a quick thank you note here for the audience, please. May I please request Dr. Krishna Kawar? You're online.
I'm online. Yeah.
Thank you. Thank you so much for your cooperation. We are able to hear you, Dr. Krishna. Please go
Yes,
ahead.
I'm sharing my file. I'm hearing you. Yeah. Can I share my file?
Yes, please.
Okay. Thank you.
Can you please share the thank you note, Dr. Krishna?
Sure. Should I start by presenting my paper?
The paper presentation we are continuing after 2 p.m.
Okay,
I
okay.
please request you for a quick thank you note so that we are able to wind up the inaugural session.
Okay. Thank you very much for, I'm deeply honored, humbled to receive MIT Academic Excellence Award at IEEE International Conference on Computational Engineering, Sensing Technology and Management 2025, hosted by Western Sydney University, organized by MIT University. I would like to express my heartfelt gratitude to the award selection committee and the organizing committee for this prestigious honor. My sincere thanks also go to my colleagues, research collaborators, and mentors who supported me continuously to push towards beyond the boundaries and explore innovative pathways in computational engineering and machine intelligence systems. Thank you once again for the prestigious award. I am really humbled by this recognition and motivated to continue contributing my scientific and academic community. Thank you, MIT University, for the honor. Thank you very much.
Thank you so much, Dr. Krishna. Taking out time from your industry schedule, that means a lot to us. Mr. Rajendra Chilukala, Assistant Vice President, US Bank, who has also rendered a paper.
Yeah. Thank you. Thank you for this opportunity to speak over this conference. I said, like myself, Rajendra Chilukala. I was serving as assistant vice president at one of the reputed banking company in United States, like a US bank. So I was been in this tech field for more than 13 years, like serving like a different kind of products for the major bankings like a JP Morgan, DTCC, and US banks. So I was been in the kind of serving like major products for the millions of users, and I would say like getting this award is a very honor for me and for this organization from the whole Amity and the whole team. I would say like we thank for this honorable award for me. Thank you so much.
Thank you so much, Mr. Rajendra. That means a lot. Mr. Arun Kumar Yadav, Senior Finance System Leader and Expert, AI, ERP, FinTech, SCL Technologies, USA.
Hello, everyone. Thank you. I'm truly honored to receive this award from MIT. I come from a IT background where I work as an Oracle cloud consultant, and I work with multiple business in transforming their existing ERP with some automation and consult them the best practice around the accounting and finance structure. So currently, I'm also pursuing my doctoral in business administration. So this recognition really means a lot to me and to my future career as well. Thank you so much in recognizing and uh, providing this award to Amity.
Thank you so much, Mr. Arun Kumar Yadav. Mr. Ankur Tiwari, AI Powered Content Management, Architect, Moaro, Toronto, Canada. May I go ahead with Mr. Jagdish Vasanthada, SAP Ariba Enterprise, Architect and Project Delivery Manager, Atlanta, USA. Mr. Arendra Tyagi, Head of Oro Originations Technology, Wells Fargo. Okay, Mr. Jagdish.
Hey, just
Please
wanted
go
to
ahead.
say, yeah. Hi, thank you. Thank you for giving me the opportunity to speak. I'm grateful and honored to receive this award. I work in Dallas, USA. I worked for JP Morgan Chase and Wells Fargo, primarily in the fintech industry. A lot of groundbreaking research I've done in the field of fintech technology using generative AI. And my recent role at Wells Fargo, we have been launching a lot of Gen AI projects. Thank you, Amity. Thank you for allowing me to receive this award. I'm grateful and honored to be part of this conference and receiving this award. Thank you.
Thank you so much, Arendra Tyagi ji. And Mr. Jagdish Vasanthada.
Yep. Thank you very much. Thank you very much for the opportunity to speak here. And first of all, good morning, good afternoon, based out of different time zones. And thank you, MIT, for the opportunity once again and the organizing committee. Myself, Jagdish, based out of Atlanta, USA, and I work on a startup where we do most of the AI products, which are collaborated with SAP technologies. And it's very honored to receive the award from the prestigious organization like you. And I'll be presenting my paper in the next couple of hours in other sessions. And once again, thank you so much.
Thank you so much, Mr. Arendra. Mr. Krishna Mula, Principal Software Engineer, Navy Federal Credit Union, USA. And the last, Mr. Dhanisha Narappa, Senior Network Architect, Versa Network, Austin, Texas.
Hello. Thank you very much for all distinguished guests and respected organizers and the fellow experts and esteemed participants. Good morning and good afternoon and good evening across everyone across the globe. So this is Dhanisha Narappa, Senior Architect at Versa Networks, US. I have around 20 years of experience in cybersecurity across the work for the esteemed industry like Cisco Systems and ExxonMobil in the US. I am very honored to hear with the international conference organized by Amity University. And also I'm very honored to receive this esteemed award from the to bridging the gap between the industry and the academy. Thank you once again. I'm very honored to hear and receive the award.
Mr. Krishna Mula.
Hey, hi, good
Yes.
morning. So, yeah, can you hear me now? I was trying to
Yes.
join, but hey, hi,
Yes.
good morning. And yeah, thank you for this wonderful honor. I truly grateful to receive the MIT Academic and Industry Excellent Award. Yeah, so AI has transformed my journey in a meaningful way.
So yeah, today AI is part of everybody's life, and so yeah, it makes me to make better decisions in my daily life. And so yeah, my sincere thanks to the organizers, mentors, colleagues, and everybody. And this recognition motivates me to continue learning, sharing, and innovating of the community. Thank you very much.
Thank you so much once again. Mr. Shubham, are you there online? Thank you, the entire team who are the paper presenter as well as who belongs to the industry, because this integration is material while contributing to the research work. Mr. Ankur Tiwari, would you like to present your thank you note?
Yes, thank you. Thank you. Good evening and good afternoon, everyone. It's a great honor to receive Amity Academy and Industry Excellence Award. I'm truly humbled to stand among such inspiring and professional and thought leaders. This recognition reflects not only individual efforts, but also the collective vision of these I have had the privilege to work and learn with. Together, we are using artificial intelligence and innovation to transform how content and knowledge are managed, making a meaningful impact across industry, especially in Toronto and Canada area. I'm extending my heartfelt thank you to Amity and Western Sydney University for fostering collaboration between academia and industry. This intersection of knowledge is a practice in which is truly innovative and is thriving. Thank you once again for the recognition, and it motivates me to continue pushing boundaries and contribute more meaningful progress. Thank you so much.
Thank you so much, Mr. Ankur Tiwari from AI Powered Content Management Architect, Movaro, Toronto, Canada. The AI domain, which has largely contributed in the computational engineering sector in the conference. And none less to mention that we have received a total papers of 602 papers in the conference, with after a very rigorous process of selection, blind peer review process, the acceptance was 202 and the registered papers are 193, and the total acceptance rate is 33%. And it has been a hardcore effort and a humble guidance by our honorary Group Vice Chancellor, Dr. Gurinder Singh sir, without whom this conference would not have been possible at all. And I really appreciate all the keynote speakers who have been able to give time to us, for the paper presenters, for some of which we would be continuing further. And we are looking forward to the brilliant alumni session from henceforth after the lunch. So may I please call upon this session, and may I request everyone to go ahead for the lunch. Thank you. Yes, we following with the alumni session, which is starting at 2 p.m. the Sydney time. And the paper presentations for the track of the Sydney is to be continued after that. Thank you.
Thank you, Dr. Shweta. I would request Mobin to please close the link, IT team to please close the link. We will join the alumni session on the alumni link. Thank you, everyone.
Thank you.
Thank you so much.
Thank you.